So now we're going to move on in the church exercise. We're going to do the volume calculation. We're going to calculate the pre-development, post-development volume of runoff using the NRCS method, and then calculate the difference that we have to handle. So the first thing we need to do there is calculate a curve number. So we need to come up with the curve numbers for each section. Remember, we have the woods and pastures for the pre-development, and post-development we have the one side where we have a building and some lawns, and then the other side is paved. So what numbers do we use? I have a couple tables down here. There are a lot of other tables available we can use, and we may get some help from the method. For example, in the Monroe Township one, it says for the volume control for pre-development conditions, all runoff coefficients within the project shall be based on a minimum of meadow use. I think that means meadow use or better, or a lower. Better is a lower curve number, more runoff is a higher curve number, but I'm not completely sure what minimum means in that case. Forested sites will use something that says forested, and other than that we can look up for that particular land use. So let's go back here. I'm going to choose for the pre-development, I'm going to choose forest, soil type B, woods. I'll say fair. So I'll give this a 60 here. And then for the right hand side of it, I'm going to use the meadow for soil type B. That's a 58. Soil type A is 30, so it's quite a bit different. Again, different soils drain differently, but that seems like a big difference. So I'll do a 58 there. So I'm going to do a composite of that. So it's the left hand side is 60% of this site, so 0.6 times 60. The right hand side is 40% of the site plus 0.4 times 58. Well, it's going to be like almost halfway between those two, right? Yeah, and so it turns out to be 58.4. For the post-development, I'm going to say that on the church side, that most of that is, I'll use a open space, poor condition. So I think it said in the this isn't necessarily Monroe Township, but I think it implied kind of fudge high on the post-development to be safe. So I'm going to say that part is a 79, and the church is actually impermeable. If you look here, paved parking lots, roofs, driveways, 98. And if I do certain things, you can get credits for these, for doing certain practices, certain best management practices. You can get credits on your curve number, or maybe on your impermeable area that you use to calculate that. So check into that. And then this part is actually, if you divide up the area, this is, the 79 is 0.54 of the area. The church, of the total area, the church was 0.06 of the total area. And then the right hand side is all paved, so that's a 98. And that's 40% of the whole area. And that equals 87.7. So we're going to use those numbers, 58.4, 87.7. So they were, pre was 58.4, post was 87.7. By the way, our P, we looked this up earlier, 2.88 inches. So that's how much it's going to, that's the design storm that we're going to design for. So we're going to calculate the runoff from that. First of all, let's calculate the S. It's 1,000 over the curve number, so 58.4 minus 10. And remember, it's this. I keep saying this because I've seen it like every test I've ever given. Someone will put 1,000 minus 10 over 58.4. And that turns out to be 7.12 inches. For the post, it's 1,000 over 87.7 minus 10, and that turns out to be 1.4 inches. So that's a big difference. So the post, the curve number is like 1.5 times the pre-development curve number, but the storage is like 5 times more for the pre-development. It can store 5 times the amount of water. So what we're looking for is the runoff Q. We like to use Q for a flow in fluids things, but this is actually not a flow, it's just the inches of runoff. So it's P, that's our 2.88, minus 0.2 times the S, which is 7.12 inches. Don't forget that square there, and then on the denominator it's 2.88 plus 0.8 times 7.12, and that turns out to be 0.25 inches. On the post-development, 2.88 minus 0.2 times 1.4. So we're subtracting off a smaller number here, and we're squaring that, over 2.88 plus 0.8 times 1.4, and that turns out to be 1.7 or 1.69 inches. So again, the curve number is 1.5 times as much. The runoff is almost 7 times as much. So I'll write these up here. This is 0.25 and this is 1.69. So what's the volume I have to handle? So if I multiply that by the area of 135 and 4 zeros square feet, the pre-development is 27,776. I'll do this in feet squared instead of, or feet cubed instead of acre feet. And this is 190,183. So the difference is 162,407 cubic feet. And I can't let that run off. So I have to infiltrate it, get it to evapotranspirate, get it to reuse it. I have to do something with that. I can't let that run off. And that does turn out to be 3.7 acre feet. Size of detention pond to hold the difference between the pre-development and post-development volume. Yeah, how about, should we do our what size shall we make it? Shall we make it a ½ acre? So how deep does it have to be? 162,407 cubic feet over half an acre. 1/2 times 43,560. That equals 7.46 feet deep. Or I could have just taken this number and said, if it was 1 acre, it needs to be 3.7 feet deep, so if it's ½ acre, it needs to be twice that. So I got to do something with that water, but that's the volume calculation. The next thing we'll do is we will build on that, and we will calculate the rate of runoff a different way than the rational method. We'll use the SCS or NRCS graphical peak flow method, and we'll do that in the next video.